Alright, here we go. Today, we're talking about similar right triangles, using similar right triangles. Now, if we have a triangle ABC here, it's a right triangle, and we have altitude CD. And again, an altitude goes from a vertex perpendicular to the opposite side. Okay, so the altitude that is drawn to the hypotenuse of a right triangle, so triangle ABC is a right triangle, the altitude drawn to the hypotenuse, alright, forms or creates two more right triangles, ADC and BCD. Alright, those two right triangles. Now, all three of those triangles now, the original one and the two new ones that are formed, are similar to each other. Okay? All three triangles are similar to each other, and they are similar through angle-angle triangle similarity. Alright? Because they have the right angles congruent, all three of them have a right angle, so those angles are all congruent to each other. And then if we look at triangle ABC and triangle ADC, those two triangles are sharing angle A. Alright, so not only do they have the right angles congruent, but they're also sharing angle A. So right there, those two triangles are similar, by angle-angle triangle similarity. And then the third triangle, CDB, alright, again, it has a right angle, there at angle D, alright, so it is similar to the original one, ABC, and they share angle B. Alright, so again, those two triangles are similar by angle-angle, alright, and if the two triangles are similar, both triangles are similar to the original one, then they're similar to each other as well. Alright, and we'll look at that in this example here. Alright, identify the similar triangles in the diagram. Alright, so I want to look at the original triangle, FGH. Alright, that's a right triangle. Now I want to draw two other triangles that look like that. Alright, and I want to put them in corresponding position. So the original triangle FGH and the triangle JGH. Alright, J is the right angle, so that has to go here. So JGH, these two triangles are sharing angle H here. So this is H, and then this has to be G. And then the small triangle over here, FJG, alright, again, J is the right angle, alright, and angle F, they are sharing the original triangle, the one I have in green here, and the small one are sharing angle F, so that has to go over here, so this point is G over here. Alright, so which triangles are similar to each other, or our similarity statement? So we have triangle FJG is similar to triangle GJH, which is similar to triangle FGH. And I have them now in corresponding position, triangle 1, 2, and the original triangle. Alright. Down here, find the length of the altitude of the hypotenuse. Alright, we have stadium seating from a football stadium, soccer stadium, whatever, bleachers. Alright, the drainage pipe, segment BD here, okay, that is an altitude. And the stairs, the stadium seating is a right triangle ABC. Here's our altitude, BD, okay. What is the length of that pipe? Alright, what is the length of that pipe? Alright. So, we want to look at the triangles. So we have our original triangle, ABC, and we know the measurements, 20 feet, 30 feet, and then that distance is 10 squared to 13 feet. Alright, now, one other corresponding triangle that involves, obviously, X here. Okay? So we want to draw it in corresponding position. Here's our right angle. And the right angle is point D, so that's D. And the original triangle, that's green. And this one that I'm trying to draw, this one down here, draw in blue. This one down here. So the green and the blue triangles, okay, they share angle C. So angle C has to go here. The other one that's left is B. So B goes here. And segment BD is X. So BD is X, that's the pipe. And segment BC, we know, is 30 feet. So here's BC, that's 30 feet. Alright, so we also know these triangles are similar because they have right angles. Those angles are congruent, and then they share angle C. Those angles are congruent. So they're similar by angle, angle. Because the triangles are similar, sides are proportional. 30 corresponds with 10 square root of 13. 30 to 10 square root of 13 equals x to x corresponds with 20. Okay? So, what is the length of the pipe? Alright, so we have 10 square root of 13 times x equals 20 times 30. That's 6, so that's 600. Alright, divide by 10 square root of 13. So x equals, we can divide by 10, okay, so we get 60, and then 1 times the square root of 13, so square root of 13. Now, the one thing with a square root, remember back to your algebra days, you cannot have a square root in the denominator, so we multiply by square root of 13 divided by square root of 13. A number divided by itself is 1, and anytime you multiply by 1, you're getting the same number, we're just changing the way it looks. So what do we get? We get 60 times square root of 13, oops, over square root of 13 times square root of 13 is 13. Alright? 60 square root of 13 divided by 13 feet, which is about 16.6 feet. Okay? Which again makes sense. That seems reasonable for the problem we're looking at here. 30 feet, 20 feet, okay, 16.6 feet. Alright? Alright, now, the altitude. Again, segment CD here, that's an altitude, goes from a vertex perpendicular to the opposite side. The altitude that intersects the hypotenuse, and when we're talking about the hypotenuse, we're talking about the original triangle, triangle ABC, okay? It is the geometric mean of the lengths of those two segments of that hypotenuse. Alright, so segment CD, that's an altitude. It is the geometric mean of these two pieces, segment AD and segment BD. Okay? And these two theorems here are talking about the altitudes, alright? The three different altitudes in a triangle, and all three of them are going to be the geometric mean of some pieces of these triangles. And the altitude that intersects the hypotenuse, it is the geometric mean of those two pieces, segment BD and segment AD. Alright? Now, the other altitudes are legs of our right triangle. And again, we're talking about our original right triangle. Okay, triangle ABC. Alright, so the altitudes from a vertex perpendicular to the opposite side, so segment BC, the blue one there, is an altitude. So it is the geometric mean, okay, of the hypotenuse, the original hypotenuse, segment AB, and the piece of the hypotenuse adjacent to this leg. Again, adjacent means next to, alright? And the hypotenuse is in two pieces, segment AD and segment BD. Which one is next to segment BC out of those two pieces? And it is segment BD. Alright? As well as the altitude, the other altitude that is a leg. Alright? It goes from a vertex perpendicular to the opposite side. It is the geometric mean of the hypotenuse, AB, and the piece of the hypotenuse adjacent to this leg. Alright? So that is segment AD. So the three altitudes in our right triangles are the geometric mean of some different pieces. The one that intersects the hypotenuse is the geometric mean of those two pieces. The altitudes that are the legs of the right triangle, okay, segment AC and segment BC in this example, are the geometric mean of the hypotenuse and the piece of the hypotenuse adjacent to that leg. Okay? Alright, let's go through an example here. Find the value of y. Okay, so I know I have a right triangle, FED, and I see y here. It is a leg, so it is an altitude. All right, I know it's an altitude. That tells me it is the geometric mean. What is it the geometric mean of? It's a leg, so it is the hypotenuse, which happens to be segment FD, which is 15, and the piece of the hypotenuse adjacent to this leg, which is segment FG, so that's 4. So y squared equals 15 times 4 is 60, all right? And we look at the directions, write your answer in simplest radical form, okay? So no decimals here. 60 is not a perfect square, but are there any factors of 60 that are a perfect square? And 4 is, so 4 times 15, okay? The square root of 4 is 2. Square root of 15, 15 is not a perfect square. The factors of 15, 1, 3, 5, and 15, none of them are perfect squares. So 2 square root of 15, simplest radical form. All right, find a clearance under an overpass. Your line of sight, okay? From your line of sight, from your eyes, you can make a right triangle up to the overpass and then down to the base of the overpass, okay, or the base of the column. All right, and your line of sight is a perpendicular line to that column. All right. Approximate the height of the beam. We want to find the height of this beam here, okay? So, what do we have here? We know that 6.9 is an altitude, all right? That's a distance from you to the beam, and that's your line of sight, which is perpendicular to the beam, all right? It is an altitude, so that means it's the geometric mean of what? Well, it's the one that intersects the hypotenuse, which is the beam. It is the geometric mean of those two pieces, so x and 5. So, solve your proportion. 5x equals 6.9 squared is 47.61 divided by 5. So x is about 9.5 feet. That's x. Now, approximate the height of the beam. So if x is about 9.5, we add 5 to that for that height. Okay. The height of the beam is about 9.5 plus 5, so it's 14.5 feet. Okay? Alright, find the value of y. Write your answer in simplest radical form. So here's a problem. Please try this and come to class with any questions about this problem. Alright? Thank you very much.